how to calculate connecting vectors. This is actually quite easy. You just have to do some subtraction, and this is how it works. You have a coordinate system, you have two vectors, or you have 2 points, it's almost the same, and you have two sort of location vectors, and you want to calculate, of course, a vector between B and A. The way to do this is just to take B, subtract A, and then you got it. So it's actually very easy. I have videos of much more complicated topics, but this is really easy. Just do a little bit of subtraction, then you got it, and good. How to calculate a connecting vector? This is actually not too difficult. It just works with, you just have to know a little bit subtraction, and then you already have it, so it's not too difficult. Let's just calculate an example. Given 2 points, we have A, which is 9, minus 7, 8, and B, which is minus 4, minus 8, and 4. And we want to know the connecting vector to these from A to B. This is also an important information which is usually given in the exercise, otherwise it doesn't matter, but when it is given from A to B, it is always we take the position vector of point B minus the position vector of A. This is called the connecting vector. And by the way, my vector arrow is always like this, because I think this arrow takes a little bit more time. So what I do is always I draw just a harpoon like this, and this is how I draw the vector arrows, but it's the same, actually, just a little bit different notation. But I never had problems in any exams of this like this. So how do we calculate it? As I said, we take the position vector of B minus the position vector of A. In this case, position vector of B is minus 4, minus 8, and 4. So we just insert the numbers. Minus position vector of A is 9, minus 7, and 8. We just have to subtract minus 4, minus 9, minus 13, minus 8, minus 7 is plus 7, so it's minus 1. 4 minus 8 is minus 4. And then that's that easy. We already have the connecting vector. So memorize from A to B. A is our point of departure, B is our destination, so take B minus A. Always like this. And then I just show you maybe a picture how you could imagine it. So we have Y and X. This is in the 2-dimensional area because it's easier to show. And we have point A, point B. We have the position vectors. This is the position vector of point A. I just call it PA. And this is the position vector of B. I call it PB. Then we want to know the connecting vector from A to B. And the way it works, we said minus PA. So minus PA is the same vector, but with different directions. So the arrow is now here. And how we do it, we connect it here. So it's a parallel transformation actually. So I take the vector, since it's a vector, and this one is a connecting vector, no straight line. It means I can move it all the way in the area. I could also put it here. And as long as the length is the same and the direction is the same, it's also valid to write it here. Right? So as soon as I have vectors, vector in general is an arrow. So it does not necessarily have to be here. But the position vector, of course, position vector is usually of a points to the point, of course. But a connecting vector, if this were a connecting vector, I could move it around all the way where I wanted it to have. So in this case, I take the connecting vector and I say it's now negative, and I subtract this vector, or I add the negative position vector of point A to the position vector of point B, and then when I go from here to here and I then want to draw the result, of course then this is the result, so this would be the connecting vector, and since it's a connecting vector I can also like transform it to here. But it's a connecting vector, it means that it doesn't really have a certain point of departure and destination in the coordination system, but vector means usually just some sort of direction. It's a connecting vector, so just the direction and the amount is important. For the position vectors, it's a little bit different. They just point to, they just show the direction. They point to the point, and it's a vector, and it's not a point anymore. So just to be sure about the definitions, but the calculation of the connecting vector, as we saw, is quite easy. We just take the destination point and subtract, or we take the position vector of the destination point and subtract the position vector of our point of departure. Then we just do a little bit subtraction, then we already have it. So it's actually quite easy. And you can also keep in mind the diagram that this is also something in general if you talk about vectors, like if you have the vector v, now you have the vector negative v, how to deal with that is always very useful. But connecting vectors, I would say, is very easy. Just practice it a little bit so that you don't make any mistakes. This is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheeps.com.